All right, so we can get going here. A couple things before we start. So tomorrow is that second exam. So I've already got it, so it looks like it's published here. You shouldn't be able to access it. I think I've got it set to be at 11:15. Oh, there we go. 11:15 tomorrow. And then that goes till 3:15. That's the end of the day. Not end of the day. End of our usual kind of class period. So you can get on tomorrow anytime between 11:15 and 3:15. Once you start that exam, you'll have an hour and 15 minutes to complete it. So that'll be kind of right there on the home page under the exam 2 materials. We'll kind of go through some of the practice problems here today. If you haven't already, you didn't do the 7-7 quiz, or you haven't run this test quiz, you need to do that today to make sure that lockdown browser is working, okay, on whatever device you plan to use tomorrow. So if for whatever reason you've waited this long, you shouldn't have, but if you have an issue with it, please let me know today as soon as possible so I can make sure that you are able to get this lockdown browser working correctly for that exam tomorrow from 11:15 to 3:15. It'll be kind of like the first one, a mixture of multiple choice, fill in the blank. There might be a couple that are select all that apply, kind of similar to some of the quiz questions, and then numerical response where you have to put a number in there as well. Okay. Excuse me. So that module 9 quiz, module 8 quiz, and then the participation quizzes that are from those modules will all be due by the end of the day today, right? So once that due date passes, you'll be able to look at the answers for module 8 and 9. So if you want to look at those before you take the quiz tomorrow, before you take the exam tomorrow, some additional review could be coming from those quizzes. But those practice problems have been out there the entire week. So hopefully you've taken a glance at some of those as we work through material. We'll finish up those last couple slides of module 9. I'll kind of relate that to the practice problems that have the questions that would be kind of corresponding to that. And then after we do that, we'll jump right into those practice problems. So any logistical questions from me before we kind of get going here? And I also put up the next module reading for Monday's class. So we'll start module 10 on Monday. So that'll be set to be released. It looks like I don't think you can access it until after the exam tomorrow. After the exam tomorrow until the beginning of class on Monday, you've got time to kind of get on and get that module reading for module 10 done. Okay. All right. So we left off with this module 9 material. Thinking about different types of markets, we kind of talked about, very competitive markets or when we only had one firm, a monopoly. We had a measure of concentration of that market. So the more concentrated a market is, the more of the market share is with a smaller number of firms. So if we ever had one firm, the total 4-firm concentration, there was only one firm, so it'd be 100%. Now, let's say I had 4 firms evenly splitting it, 25 plus 25 plus 25 still would be 100%. So anytime we have 4 firms or fewer, we have the same 4-firm concentration ratio. So it doesn't really allow us to differentiate between very concentrated markets, right? But we know that having a monopoly, one firm, right, that's more concentrated than having 4 firms that are splitting it evenly. So how would I compute these 4-firm concentration ratios if I had an example like this? Well, I've got the top 4 firms, every other firm in the industry, add these all up to get the total. So that would be my denominator. These top 4, those are the market share of the top 4 firms. If I want it in terms of a percent, I didn't turn these into percentage, so I technically should have multiplied that by 100 so that I get something that's in between, right, 0 and 100%. In fact, you should have something above 1%. I mean, sure, there is an industry where potentially the 4-firm concentration ratio is below 1%, but I won't give you any examples of that. You should be getting a value in between 1 and 100. Okay. So if I had an example like this, so I've got operating systems, top 2 firms are the majority of the market share. In fact, the top 4 firms, well, if every other firm in the industry only has 0.1%, the top 4 firms, when I add these up, that's going to be 99.9% of the overall market share. So even though this firm doesn't have this market doesn't have a 4-firm concentration ratio of 100, it's very close. It's heavily concentrated, or most of the market share is with a very small number of firms. So if we look at different industries, this varies. video game consoles, there's only a couple. And so take the top 4 firms are like the only 4. I don't even know if there are 4. I think I've got a visual in a second where there's only 3. And so they would add up to 100%. Whereas we have things like automobiles, there's a lot more than 4 manufacturers. And so we end up seeing a 4-firm concentration ratio there, something below 100%. So a better measure of market concentration that's going to allow us to delineate between or differentiate between like 1 versus 2, 3, or 4 firms is going to be this HHI. So what we're going to do is take the market share, and this is the market share in terms of the percentage. So this would be like 10%, 15%, etc. You're going to square the market share of every firm in the industry and then add them all up. Okay. So I think I left the slide here for examples. We'll kind of come back to this one in a second. But if I'm thinking about the HHI and I only have one firm, right? So if I had one firm, what would their HHI be? Well, 100 squared is 10,000. So 10,000 is the highest index we could ever see for market concentration using this HHI. Let's instead think about, okay, what if I had 2 firms evenly splitting market share? Well, there I would take the market share from the first firm, square it, add that to the second. So if I have them splitting it evenly, it'd be 50% squared plus 50% squared. I end up with 5,000. Now, why the HHI is a little better? Because even if I had the same number of firms, but now let's assume that one of them has 10%, one of them has 90%. Well, now when I compute this, this would be what? 8,200 if I'm doing math in my head correct. So notice, even with the same number of firms, the HHI is telling me this market is more heavily concentrated with one of those firms, whereas in the other one, they were evenly splitting it. And this will apply as we go to 3 firms, 4 firms, 5 firms, 6 firms. It still allows me to, when the number of firms is the same, still pick up on the fact that there might be heavier market concentration if one of those firms has a very large market share. Okay. And the reason why this works is because when I square a value, 1 squared is still 1, so that would get added to my HI, but 2 squared is 4, so instead of adding 2 when I square, I'm adding 4 in there. 3 squared is 9, right? Squaring these market shares, you can kind of think about it, it over penalizes one firm having a very high market share. So it's going to increase my HHI. So if we want a very competitive market, we want to see an HHI that's really close to, or as close as we can get to 0. Even if we had, 100 firms and each had 1%, well, that would still be an HHI. 1 squared 100 times would be 100. So, we're not probably going to ever see exactly 0, but we'll see things that get closer to 0. Okay. So the example I had here, same kind of operating system. With a 4-firm concentration ratio, it was almost 100%. Well, with the HHI, it's not going to be close to 10,000. That would be if we had like a monopolist, right? I will take each firm's market share, square them, and what I see is, okay, this is a pretty heavily concentrated market. We said when there was 2 firms evenly splitting, that was 5,000. So even though we have more than 2 firms here, most of the market share is with 2 firms, so we get an HHI not as high as 5,000, but somewhat close to that. Okay. So the HHI allows us to identify the types of markets, which is what we'll cover each individual type of market after the exam. Okay. So, some video game console here, if I did the HHI, 37 squared plus 20 squared plus 43. However, the 4-firm concentration ratio would be 100%. And then, we can think about less concentrated markets. If I look here, I've got 3 firms kind of evenly splitting. Here, I've got 2 firms, but I've got a couple down here. Probably has a lower HHI if I go ahead and calculate this. And then if I had the numbers here for beer producers or like automobile, well, here I've got them, the market share split amongst a lot more firms. This is going to have an even lower HHI. Okay. So being able to calculate an HHI is something you might be asked to do, which is what these problems look like, right? So you'll be given some, hypothetical market. Here, I think this was like, laptops, or maybe it was phones. And you've got, 5 major companies, and we just, for the sake of making it simple, say there's only 5, okay? Now, the 4-firm concentration ratio, You don't just add up the first 4 firms you see, you add up the market share of the highest 4 firms. So 46 plus 32 plus 10 plus 8 would give us that 96% 4-firm concentration ratio. If I wanted the HHI, I'll use Excel to be my calculator here. What I would go through and do is say, okay, take the highest firm's market share, square it, add to that the next highest firm's market share, square it, add to that the next highest firm's market share, square it, next highest, squared. Now I don't stop at 4 with the HHI, right? I do every single firm in that industry, so I would also add in the 5th highest here as well. Once I hit enter here, I get that HHI of 3,320. Okay. Any questions on that idea before we keep moving? Just to kind of solidify this, what if I added a 6th firm here? What would have to happen to my HHI? If I add a 6th firm, their market share is going to be something above 0, which means somewhere one of these numbers is going to go down, right? So if I'm calculating of the 6, if they're only having a small percentage, it's likely that we're going to see that HHI decrease as we add more firms to this market, as long as the market share, doesn't all shift towards Apple or something like that. Excuse me. Okay. Any questions on that before we keep moving here? So that really should be about it for HHI. I would review some of those last problems in the practice problems for Module 9 as well. Had a couple additional problems that you could kind of work through. I can almost guarantee, since I wrote the exam, you will likely see something that looks similar to this, where I give you the market share of the firms, and then you have to calculate an HHI. I would focus more on that than the 4-firm concentration ratio. Okay. All right. So with that idea in mind, I will now kind of field questions from you guys. So I actually already posted my earlier sections. I put it on your playlist as well. So we might cover some of the same problems, but I just want to put it out there, if you're looking for additional, if we don't get through the questions, all the questions, which I know we won't go through all of them here today, but there's some that we didn't cover. Maybe we covered in the other section. That'll be available on YouTube as well. Okay. So any questions people want to see me start out with here? This is kind of the purpose of today's class. There's no participation quiz for today. It's just kind of for review, preparing you for that second exam. Nobody has any questions? Preference, more recent stuff from further back.
30.
You can use the chat. No one?
Can you do 28, 29, and 30?
Yep. Thank you. Yeah. So you will likely have something like this where I give you some information, but not others. Okay. So here I've got a table, and I only give you a couple pieces, and I asked, what are the total fixed costs for this firm? So just as kind of a hint, I don't have any total fixed costs. I also don't have any average fixed costs here. So it might be like, how am I supposed to figure this out? If you're looking for fixed cost, a good quantity to always look at is going to be 0. Because what's the only type of cost, even if I left this out, what's the only type of cost we have when we're producing nothing? Well, if we're producing nothing, we don't need to hire any workers. So 0 variable cost. Okay. What are my total cost of 700? All of that must be coming from my total fixed costs. And my total fixed costs don't change no matter, they don't depend on the quantity I'm producing. So that should just be always the same. And I'll kind of do those ones next. Okay. So that's 28, right? Now I could have complicated this a little bit and said, maybe what's the average fixed costs? So first of all, before I do that, the second part of the question, so I don't skip it, why do I know that these firms are in the short run? In the short run, we have fixed costs. In the long run, we said everything's variable. So the only way we're in the long run is if that total total fixed cost was 0. But we knew it wasn't here because we had total variable costs were 0 and my total costs were still 700 when I produced nothing. That must mean that's all of my fixed costs. Okay. Now, if I'd asked you for the average fixed cost, and let's say of, a quantity equal to 2, well, I didn't have this information. In order to know my average, we said the average fixed cost is equal to my total fixed cost divided by quantity. So I would first have to find my total fixed cost like we just did, but then I could fill out this entire column because the average fixed cost is just total fixed cost divided by quantity. So 700 over 1 is 700. 700 over 2, 350. 700 over 3 is going to be what? 233.33 repeated. And then 700 over 4, it's going to be what? 175. I'm doing math in my head correct here. Okay. So what is always happening to our average fixed cost? As we produce more units, that same $700 is being spread out over more units. It's decreasing. Okay. What if I wanted the total cost of the 4th unit? Okay. Well, that one's a little bit trickier. What do I need to do in order to find my total cost? Well, if I knew my total variable and my total fixed, I could add those together. I don't though, but I do know my average total cost. Right? So my average, any average we're looking at is going to be that cost divided by quantity. So I was looking at the 4th unit. If I look in that table, no, I already forgot. Yeah, the average total cost was 200. It's just a little bit of algebra here. Multiply both sides by 4, and I get that my total cost is equal to 800 at that quantity of 4. Okay. That's not what I want to do. There we go. So 800. Okay. What if instead I wanted to find the marginal cost of the 2nd unit? Well, this one's going to be a little more involved. So the marginal cost is the change in my total cost divided by a change in quantity. Well, here, kind of help you out. The changes in quantity are only 1, so that makes that part easy. So in order to find the marginal cost of the 2nd unit, I need to know the total cost of the 2nd and the 1st. Well, here, what's the total cost of my 1st unit? That would just be my total variable plus my total fixed. So 710. So at that 2nd unit, what's the change, right, in my total cost? 40 divided by a change in quantity of 1, or just to kind of remember, our marginal cost is just the change in total cost over the change in quantity. So we had 40 over 1. That marginal cost should be 40. Okay. So, oh, there it is. Should be 40. Now, let's say I left out. Let's say I did this. Well, I'd have to do something even trickier, but like, let's say somehow, oops, let's say somehow I left out a bunch of information so that all you had was this, right? And you couldn't fill in, gosh, bless it. There you go. And you couldn't fill in these total costs or total fixed costs. So if I asked you for the marginal cost here, okay, I can't find the total cost, right? Or, well, I want to try to put this. Yeah, so I can't find, let's say somehow I gave you, I don't know, this, instead of doing it the other way. There's another way you could do this. So if my total costs are 750, my total fixed costs are 700, what is my total variable cost at a quantity of 2? 50. Right? So even if I didn't have these total cost and like fixed cost values, if I knew my variable costs, well, what is the change in my total cost always coming from? My fixed costs are always the same. So the change in my total variable cost, so we could actually do marginal cost is the change in our total variable cost divided by quantity. There we were going from 50 to 10. Notice I get the exact same value of 40. So when you're calculating marginal costs, maybe sometimes it'll save you some time, or it might be easier given whatever table I'm showing you. You can use the change in total cost. You can also use the change in total variable cost. They both should be the same thing. Excuse me. Okay. Any questions on any of those three before I go to the next ones that were asked about? And I forgot 22 and 23. Okay. So if we go back here. Yeah, so if I'm thinking about 22, which of the following will allow us to get to a higher indifference curve? Okay. So we have a decrease in income, decrease in the prices of one good, or an increase in the price of another good. Okay. So we're thinking about these things that can change our consumer optimum. We've got a couple different scenarios. So the first is whatever two goods I have, and here I know there's specific goods you could write in what your X and Y is. So I think here it doesn't matter. So let's just assume I put, I don't know. So I've got hamburgers and I've got Den Pops up here. Okay. If I saw a decrease in income, well, what is that going to do to my budget constraint? So initially, this is the highest indifference curve I can get to given that budget constraint. Okay. I would like to be on even higher indifference curves. But what's true about all those points? Well, they're past my budget constraint. Every point past this, I can't afford any of these points. I can just barely afford this one. So that's the highest indifference curve I can get to on my current budget constraint. If I have less income, what's that going to look like? If I have less income, that means if I'm only buying hamburgers or I'm only buying Den Pop, I can buy less. So this is going to be like a shift downward. What is now true? I can't get out to this higher indifference curve. Now I'm constrained to being on an even lower indifference curve. Okay. So that one can't be the case. I'm looking for what puts me on a higher indifference curve. What if the price of Den Pops increases? That was one of our other options. If the price of Den Pops increases, if I'm only buying Den Pops, what happens at this point? So where do these points come from? We would take our income and divide it by the price of that good. That's how much I can afford to buy if I'm only buying this good. So the price of Den Pops goes up. I can't afford as many as before. My budget constraint, it doesn't like parallel shift down, but it gets kind of like lowered. So I no longer can afford this point. Now the highest indifference curve I can get to is going to be lower than before. So, if I'm putting values to this, higher indifference curve represents higher amounts of total utility. I'd be at a lower level of utility than before. So that's not going to be the one. What if I saw a decrease in the price of hamburgers? Well, if I'm only buying Den Pops, that point doesn't change. But how was I coming up with this point? It was income over the price of the X good. So now, if the price of hamburgers is lower, I can afford to buy more. So my budget constraint shifts out here. Now notice what's true. There's going to be some indifference curve here. That's a higher amount of total utility that I can now afford to get to. Okay. Yeah, we'll do those problems next. Okay. So we're thinking about which one allowed us to get to a higher indifference curve. That's going to be not a decrease in income and not an increase in price. This is kind of intuitive. When am I going to be happier? When can I afford to buy more things? Either when income is higher or if the price of goods goes down. And think about it in another way. What do these intercept points really represent? It's kind of like our real income. It's our income divided by how much things are costing. If things are cheaper, the same income has more value. So it's going to be able to allow me to get to a higher indifference curve. Okay. So on 23, let me make sure, I think it was 22 and 23, yeah. So I've got the same setup, but I'm giving you income, I'm giving you the prices, and I'm telling you the margin utility, okay? So this one is definitely a little bit trickier here. So we're not thinking about shifts in our budget constraint now, but we're thinking about And I'll give you a graph that would help you solve this. I'll then show you a way that you don't necessarily quite need a graph, okay? So I had income was $20, price of these Den Pops was 1, price of a hamburger was 2, and I think I said the margin utility of the last Den Pop was 10, and the margin utility of the last hamburger was 15, okay? So I can build out my budget constraint, right? I know that, okay, if I'm only buying Den Pops, how many total can I afford to buy? The income over price, so that would be what? 20 over 1 or a quantity of 20. If I'm only buying hamburgers, income over that goods price, I'd have 20 over 2 or 10. So what is the slope of my budget constraint? The slope of our budget constraint will always be negative price of the X good over the price of our Y good. So in this case, the price of our X good, hamburgers, is 2. Price of our Y good, Den Pops, was 1. I've got this slope of negative 2. Okay. So we know that when we're spending optimally, right, it should be that the slope of our indifference curve is the exact same as the slope of our budget constraint, okay, at this point, okay? So what does that imply, okay? What that implies is that the marginal utility of the X good over the margin utility of the Y good is the same as that relative prices, because the slope of my budget constraint is the relative price of X to Y. We said the slope of our indifference curve was this marginal rate of substitution, or the margin utility of X over the margin utility of good Y. Okay. Now, I've got all these values here, and what I can actually see is, okay, if I were to plug these in, I've got what? My X good was hamburgers, so 15 over 10. Well, that's not the same as my relative prices, okay? In fact, this marginal rate of substitution, it doesn't, I don't have a slope of negative 2. It's actually what? Negative, since it's downward sloping, my marginal rate of substitution would be negative 1.5. So I know I am somewhere where I'm at an indifference curve. So I must be on an indifference curve where, wherever I'm at, the slope is actually flatter, right? So that can't be my consumer optimum. That the consumer optimum, that marginal rate of substitution, should be equal to those relative prices. So what should I do? Well, I know that I must be somewhere over here. I need to buy more Den Pops and fewer hamburgers, okay? Now, another way of thinking about this, I wish I had more space in this classroom. I keep hitting the mouse. There we go. Is I could simply, oh yeah, if this has to be true, when we rearrange this, we said what is that fact that those two slopes are being equal at that point saying? It's that the margin utility of our X good per dollar we spend is the same as the marginal utility per dollar we're spending on the Y good. So for our X good hamburgers, that was what? 15 over 2. Den Pops, we had 10 over 1. So 7.5, 10. If the marginal utility per dollar is higher for our Y-axis good, what should we do? And, to put this in the context of our examples, this was hamburgers and Den Pops. Well, we should buy more of whatever good is giving us a higher margin utility per dollar, which means the quantity of Den Pops should go up, quantity of hamburgers should go down. Okay. So we should buy fewer hamburgers, more Den Pops if this was the scenario. Buy whatever has a higher margin utility per dollar, which is also what we were saying here, right? Buy fewer hamburgers, more Den Pops until we get to that consumer optimum point. Okay. Any questions on that? Okay. Let me think if there's something else I want to mention here. I think that covers it. So I think that was the two that we had been asked about. It's 22 and 23. The next one is so 12 to 16. Let's see, what was that about? Is that tax stuff? Yeah. So going back, like modules kind of 7 here. So 12. Let's assume that we have this good. So vaccination, it's a positive consumption externality. So we've got a positive externality. Doesn't matter where it comes from. It's a positive externality. It's an additional benefit. If we have no government intervention, what's going to be true about the equilibrium price compared to the socially efficient price and the equilibrium quantity relative to the socially efficient quantity? Now, I even threw in here consumption. I'm not going to ever throw in this to try to trick you, but if we have a positive externality, we should always be modeling that through what? So we have our market. We've got an upward sloping supply curve representing the private marginal costs, downward sloping demand curve representing consumers' marginal benefits. Where supply is equal to demand, that's going to be our equilibrium price and quantity for the market. Okay. If I have a positive externality, what that was saying is that at every quantity, there's an additional benefit to society, right? So the marginal social benefit is higher. Okay. So the marginal social benefit, where does that hit? Well, we don't have any negative externalities here, so our marginal costs are just the same as our social costs, marginal social costs. Excuse me. So the society, the quantity that they would find increases their surplus the most is going to be where marginal social cost is equal to marginal social benefit, which would be at a higher price and a higher quantity. Okay. So some additional questions we could then be asked. So that should answer this one, right? The equilibrium price is going to be less than, and the equilibrium quantity in the market will be less than what is socially efficient. Okay. However, I have that same positive externality. Let's think about deadweight loss and how we could correct for it. So in that question, it might be even a little bit easier than you would see in the exam. So I just asked you, was it 0 or something above 0? Well, anytime I have any type of externality, we know deadweight loss is going to be created. So we should have automatically knew it's not going to be 0. It has to be something above 0. But let's say I gave you a visual and I asked you to calculate what deadweight loss was. So when we have a positive externality, the market is producing a quantity that is too low. So when we're thinking about surplus, it's the difference between the marginal benefits and the marginal cost of whoever we're looking at. When we're looking at society's surplus, that's going to be the difference between society's marginal benefits and society's marginal costs. So for every unit that the market is not producing in this range, what would society's surplus have been? Well, for every unit there, the marginal social benefit is above the marginal social cost. So we're missing out on all of this surplus. This would be society's deadweight loss. I can even kind of, right, society's deadweight loss here. Okay. So we know that there will be this deadweight loss that exists, and it's going to be from every unit that we're not seeing the market produce, there would have been some positive surplus of those units to society. Now, how can I correct for this? We said the only way that we can increase the quantity in a market is to do what? We could give consumers a subsidy. In fact, technically, this is the easiest way to think about it. But even if I gave producers a subsidy, what would that do? Well, that would actually lower their costs. So I could actually give a subsidy to producers or consumers and push it out to this equilibrium quantity. Okay. Or I shouldn't say equilibrium, sorry, the socially efficient quantity. Push that equilibrium quantity out to the socially efficient quantity. Okay. Excuse me. So forget. So that's 12 and 13, 14, 15, and 16. Kind of round this out here. 14 is basically, when we're looking at this comparison, it boils down to the following, right? So if I have additional costs being created, okay, so we kind of already talked about some of this, but anytime you're going through these problems, always think about what I could change. So here, I think the problem was saying there's like an additional cost. So anytime you have an additional cost, that's going to be a bad thing or a negative externality. What is true about a negative externality? Whatever the marginal costs are in the market, because there's this additional cost, society's costs are going to be higher than the people in the market, right? Because we'll have the cost from the people in the market plus this negative impact pollution or noise or something is having. Okay. Anytime I have an additional benefit, well, that's going to do what? That's a positive externality, right? That's a good thing to people outside of the market. So the benefit to the market will be whatever the benefit is to the consumers. However, plus some additional amount to society. So society's marginal benefits will actually be a little bit higher when we have a positive externality. Okay. And then we model those as, I kind of already did one. I'll do the negative one here in a second. So we're thinking about how did I model those positive externalities? If I can get this paper. There we go. We said, ignore the subsidy stuff here. We model them as society's benefits are higher than the demand curve. Okay. Now, let's say we had negative externalities. What is that going to look like? Well, I'll do this very quick, saving us time to get through more problems. All right, so here is our market equilibrium. If I have a negative externality, that's telling me that society's costs are higher. We said we're always going to model that through our supply curve. So with a negative externality, the market actually produces a quantity that's too high, right? As a result, what's the loss to society? Well, a lot of times people will confuse this and look at this triangle down here. But actually, technically where it's coming from, when the market is producing too many units, what's true about every unit in this range, the marginal cost to society, there's no positive externality, so the marginal benefits are just society's benefits. The costs are greater than the benefits for every unit in this range, which is why this is creating deadweight loss. Okay. So if I've got a negative externality, how can I solve that? Well, I can't use a subsidy that encouraged more, right? That increased the quantity. So what can I do? Well, how can I make the supply curve increase and match up with society's costs? I can impose a tax that would then push the quantity to be down here. I could also impose an effective price ceiling, right? It doesn't allow the price to get any higher than this, limits the quantity down here. I could also impose an effective price floor, would also kind of push the quantity down. So with a negative externality, we have multiple solutions. We have effective price ceilings, effective price floors, and a tax. Now, when you're looking at some of these questions, and this one, it doesn't have it specifically. If you look at some of the practice problems from that module or the quiz questions, anytime you're thinking about price floors or ceilings, if I'm giving you an actual value, you need to make sure to see is it effective. So for example, if I had a tax example or a negative externality that looked like this, and I told you, okay, you can tax this, right? So that you can make the supply curve match up with society's marginal costs. What if I told you, well, what if I imposed a price floor of 40? You might look at this and say, okay, yeah, that would push me down to this lower quantity as well. Well, if it's a price floor, that means I can't charge a price below 40. What's the current equilibrium? 50. That would be an ineffective price floor. What would actually happen in that market? Absolutely nothing, right? We couldn't push the market back down to this quantity because it's an ineffective price floor. So if you're given specific values for price ceilings and price floors, make sure that you're checking to see if they're effective. In this problem, I told you, one of the options was it was an effective price floor. But if I was giving you the graph and then asking you, okay, would a price floor of this value, would a price ceiling of this value kind of push us to that socially efficient quantity, you need to make sure if they're efficient or inefficient. Okay. So here, the only one, and quotas, we can always limit the quantity. So really, we have multiple tools for solving a negative externality, but we only had one tool to increase quantity for those positive externalities, which was subsidies. Okay. And then 16, this is really just kind of definitional stuff. I would make sure I know each of these 4 different types of goods and the characteristics that define them. So in this example, when we had something that was free access to public parks, but they become very busy so that they're rival. Well, if it's free access, right, we had 2 characteristics: rival, non-rival, excludable, non-excludable. If it's free, you don't have to pay for it. It's non-excludable. Anyone can go use it. So if we think non-excludable, this was public goods and then also common resources. Okay. Now, if it's very congested, so it becomes rival, so me going to that park is preventing other people from actually going in and using it or enjoying the marginal benefit as well. Well, that was when it becomes rival, we said a common resource. If it was non-rival, it'd be a public good. So when a public good becomes overused, like a public park, and it becomes rival, it would then switch categories to be what we call a common resource. Okay. 20 and 22. Right. Yeah, so I think we already did 22 at the beginning here, but I'll do something that'll kind of get at it, I think, through answering 20. 21, sorry. So we'll do 20 and 21. So let's say we've got textbooks, pizza, income, and the prices. What will the marginal rate of substitution be? Okay. So in this one, I would have to actually tell you what good is on the x-axis. I think I said textbooks. Okay. So I'm just going to write these things down so I don't, well, I can see them. There we go. So we have income is 300. Price of a textbook is 60. Price of pizza is 20. So I could think about if I'm putting textbooks on my x-axis, pizza on my y-axis, right? And I want to know what's the marginal rate of substitution here. Well, I know that when the consumer is spending optimally, they're going to be facing this budget constraint where the amount that they're buying of the X good will be their income divided by the price of that good. So, oh, nope, textbooks were $60, sorry. So if I'm only buying textbooks, I buy 5. Up here, if I'm only buying pizza, it's my income divided by the price of that good. So 300 over the price of that good, I'd get what? 15. So I can use these quantities now, if that's what I'm more comfortable with. I can use the income and prices to figure out what these intercepts are. If I'm only buying textbooks or only buying pizzas, what is the change in the quantity of my Y good over the change in the quantity of my X good? Well, negative 15 going from this point to this point. X would be going up by 5, and I get negative 3. But what did we say is always going to be true? The slope of this budget constraint will always be the relative price of the X good over the price of my Y good. In this case, the price of textbooks over the price of pizza, 60 over 20. Sure enough, I get that same slope of negative 3. Okay. Now, why does that help me? I wanted to know what's my marginal rate of substitution. Well, we know that at the consumer optimum, we'll be at the highest indifference curve possible given that budget constraint. And what should be true here is the slope of my budget constraint is the same as the slope of my indifference curve. What's the slope of my budget constraint? Well, we just said that's the relative price of good X over the price of our Y good. Okay. What's the slope of our indifference curve? It's the marginal utility of our X good over the marginal utility of our Y good. So it should be that these slopes are the same at that point. So the marginal utility of a textbook is the same as the marginal utility of, the relative prices will be the same as the relative margin utility of a textbook over the margin utility of a pizza. Now, notice I have a negative here. Technically, this slope is always negative. When we talk about the marginal rate of substitution, because it's referencing how many of the other good in terms of units I have to give up to get one more unit of the x-axis good, and I won't ever try to trick you with putting positive and negative answers there, we typically just always drop that negative sign, right? It's already reflecting how many units we have to give up, so it's already inherently like a cost. So here we're just looking for the absolute value, okay? So I know that the slope of my budget constraint is -3, and I could have done that finding the quantities or simply using the relative prices. So I know my marginal rate of substitution should also be 3, right? Or that slope of my indifference curve is -3, representing a marginal rate of substitution of 3. Okay. I think other questions on that one. So I'm going to add in something that maybe the problem didn't ask for, but I could ask you to do this. Let's say I gave you the prices of these two goods. So this was 60 and 20. I then told you the marginal utility of the last textbook that you bought was 80. I then said, what is the margin utility of the last pizza you bought if you're spending at that consumer optimum? Well, there, it still hinges on this idea. You know that at the consumer optimum, the relative price of good X to good Y is the same as the relative margin utility of good X to good Y. Okay. Well, now it's just a little bit of algebra, right? So I would multiply both sides by the margin utility of pizza. This is 3, so I divide both sides by 3. I get what? 80 over 3, right? So this is going to be, oh, what? 20, no. Yeah, 26.66 repeated if I'm doing math in my head correct there. Okay. And I probably wouldn't ask you one where you have like repeating. I'll give you slightly. I'm just kind of coming up with this off the top of my head here. So I could ask you something like that. Now, I also want to make a point here when you're working through these. If you're ever trying to find the slope of your budget constraint, it 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 may be easy to forget when we're looking at relative prices, it's the price of X and the margin utility of X that is in my numerator. When you're using the quantities, it's still, right? The visual from the quantities is you have to take the change in whatever's on your y-axis over the change in your x-axis, okay? But when we look at the relative prices, it's because, and we walked through it when we did the module, because like they are actually like embedded in the quantities, but they're in the denominator, if things get flipped, it ends up being that when you're using prices, those slopes are going to have your x-axis good and top when you're looking at the relative prices and you're looking at that marginal rate of substitution. Okay. So that was question 20. Question 21, I would kind of similar to what we just worked through. I would be more concerned, or I would think more about a question where I give you two prices and I give you the margin utility of one of those goods. So if I'm doing this video game movie ticket example, I'll work through this one for you, but I would almost probably like make it a little bit easier in a sense. So because you know that the marginal utility per dollar spent on a good should be the same as the margin utility per dollar you spend on the other good. So this is movie tickets and video games. And that was really just coming from rearranging this idea that the slopes will be the same. If I rearrange this, I'd have the margin utility of a ticket over the price of a, textbook over the price of a textbook, margin utility of a pizza over the price of a pizza. What that's really saying is when those slopes are equal, when that relative price is equal to the marginal rate of substitution, the margin utility per dollar we're spending is the same for both goods. So if I told you the price of video games is 40, I told you the price of a movie ticket is 10, what has to be true about the margin utility of a movie ticket to a video game? So this is what I would do in this one. I would start out here and think about how could I make the margin utility of both of these goods equal to 1? If I did that, what would the marginal utility of video games have to be? 40. What would the margin utility of a movie ticket have to be? 10. Right? So if these both had a margin utility per dollar of 1, that's going to allow me to see what the direction of this relationship has to be, that the margin utility of video games always has to be higher. In fact, how much higher? Well, if I took this, and once again, I wouldn't probably push you this far, but if I rearrange things a little bit, and I just multiply both sides by 40, what this is really saying is that if we're spending at that consumer optimum, 40 over 10 would be 4. The margin utility of a video game must always be not twice as large, 4 times as large as that of a movie ticket. And I could put more hypothetical values. Making this 1, I think, is the easiest way to see that. But to prove this to myself, well, what if the marginal utility was 80 for a video game? Well, 80 over 40 is 2. So what would the marginal utility have to be for a movie? It's getting divided, so it would have to be 20. Sure enough, it's still less than. In fact, how much lower is the marginal utility of a movie ticket? 4 times as low. Or said differently, the video game has a marginal utility 4 times as large. Okay. I'd be more likely to probably do an example where I tell you the margin utility of one of the goods and ask you what the margin utility of the other good has to be. Okay. All right. Any other questions? Let me make sure. Did we cover, what was the last one asked? 21. Did we? Yeah, we just did 21. Any other questions people want to see worked through here? Or just questions in general about a certain topic or? Okay. Let's work through, because I know that you'll have something kind of similar. Let's do 25 here. So we want to be able to think about specifically how we break down the total effect of a price change into the substitution and the income effect. Okay. So if we're thinking about 25, I'm telling you, you have this amount of income. Price of ramen, or sorry, packets of ramen starts out, you're buying 10, 5 ounces of caviar. You then see the price of ramen noodles decrease. Your new utility maximizing point is 12 and 4. Excuse me. So you know essentially the total effect, right? But we want to break down what this substitution effect and the income effect are going to look like. So if I want to put a visual to this, and I've got ramen here, and I've got my caviar here, and I was currently, initially I started out, I was buying, 5 ounces of caviar. Oh, no, I already forgot what it was. Is it 5 ounces and 10 packets? Right? Okay. After we see a price decrease in ramen, well, what's that going to do? Well, if I'm only buying ramen, I can now buy more. So that should push my budget constraint out. So this is now like my second scenario, my second budget constraint. Well, notice if I keep spending at my old level, I'm going to be on an indifference curve. I could get to higher and higher indifference curves. In fact, I could spend out to this indifference curve. And we were told after that price change, the quantity of caviar fell to 4, and the amount of ramen purchased went up to 12. Okay. Now, it's a little bit harder to draw this graph out for yourself. I knew the total effect, and I do this a little more often, so I knew how much to shift that, shift the budget constraint. But I wanted to give you a visual that lines up with what we're going to talk about. You don't necessarily need the visual, but this is the total effect that you're looking at. Where I was at optimally on my original budget constraint to my new one. So anytime we have a price change, we can break this down into 3 things: the substitution effect, income effect, and our total effect for both goods. So I've got ramen, and we had caviar. Right? So if the price of ramen goes down, the substitution effect should always work the same way, right? Doesn't matter if the goods are substitutes or complements, as long as they're imperfect complements or imperfect substitutes, we should always buy a little bit more of whatever is now relatively cheaper and substitute away from whatever is relatively more expensive, right? How is that occurring? Well, remember, when we see a change in the price, my relative prices are changing the slope of that budget constraint, kind of changing how much I buy. That's the substitution effect, that relative price change, right? So what did we typically do? We thought about, and I wouldn't like suggest even doing all this on your own, this hypothetical budget constraint where we said, okay, we've kept relative prices the same, or sorry, I'll do this one first. We've allowed the relative prices to change, but we're assuming we can only afford to buy the same amount of total utility. That represented our substitution effect. Now, our income effect, what's going to happen to our real income if prices go down? Well, real income, you can think of it as just income being divided by prices. So when the price of one good goes down, the real value of my income actually goes up, right? The denominator is smaller. So I would have to know what type of goods these are. So I think I told you in the problem, caviar is a normal good, ramen's an inferior good. So if I have more real income, the income effect for an inferior good will be when I have more income, I actually buy less of it. And for a normal good, when I have more income, I'm going to buy more of it. Okay. So if I think this was kind of more similar to the next problem. I forget the numbering now. But if I were to not give you the total effects, and I just said there's a change in the price of ramen, ramen's inferior, and caviar is a normal good, what's the total effect? Well, I actually wouldn't know, right? I would have to say that change, without any more information, is indeterminate. Okay. However, in this specific problem, you're using the same principles. You could determine that this is indeterminate, but I gave you the total effect. So what was the total effect here? I bought, after this price change, more ramen, less caviar. So for ramen, what had to be true? Well, they're pushing quantity in opposite directions, right? So, wait, what did I do here? I mixed something up. The total effect for caviar said, oh, I said this and no one called me on it. This arrow is going the wrong way, right? When I have a substitution effect, whatever is relatively cheaper, I buy more of. And I know I said it, but I, for some reason, wrote the arrow the wrong way. Whatever is relatively more expensive, I buy less of, right? So here I've got two indeterminate changes. So for ramen, the substitution income effect, we're pushing them in opposite directions. So if the total effect is I buy more, which of these effects must have been larger? The one that was increasing it must have been larger than the one that was decreasing it. So here, that substitution effect for ramen must be greater than the income effect because I told you the total effect is that we bought more. Now for caviar, well, I've got the substitution income effect pushing them in opposite directions. If I know the total effect is negative, going from 5 to 4, which one had to be larger? Well, here, in fact, the income effect actually has to be greater than the substitution effect has to be greater than the income effect for caviar as well. Okay. So whenever I tell you the total effect, because you can determine from a price change what the income and substitution effect are, which of the following would not be correct? Well, we said the substitution effect for caviar is negative. It's relatively more expensive. We buy less of it. The income effect for ramen is negative. Our real income went up. It's an inferior good. We bought less of it. The substitution effect for caviar is greater than the income effect. We said that one has to be true because we know the total effect is that it went down. And then the income effect has to be greater than the substitution for ramen noodles. No, we actually said the substitution effect had to be greater than the income effect. So that's the one that's not correct. Okay. What if instead I had given you that the total effect was, I don't know, for some reason I bought more of both goods when the price went down? Technically that can happen. Like if I spend a large amount of money on something and the price goes down, I now, it changes my real income so much that I might buy more of it, but also other things. So there I would have to say, okay, now which one is larger? Okay, now it must be that for caviar, the income is greater than the substitution effect. So I can only really make this comparison if I'm giving you what that total effect is. If I only tell you that there's a price change, and I ask you about the total effect there, then it would be indeterminate in these examples. Okay. All right. So that was what? 25, right? Any other problems that people want to see since I've last asked? Older stuff, newer stuff. Went through these. I think this one's kind of tricky, so I want to go through this one. Also, this problem is probably, I throw these practice exams together a little quick, and I put them out even before the quiz questions. So I would probably add a caveat to this one. The two things I would probably add is something like this. So I've got my margin or my average variable cost. Let's say my average total cost is 25, and what do I want here? Wanted to say, oh, and there are no gains from specialization. Okay. So I would kind of add in that there's no gains from specialization. Now, this should kind of be implied in a problem like this when we're looking at the graph, and I'll show why. And then the average total cost being 25 allows you to identify something about this scenario that I could also just tell you. We'll go back to 8 after this one. So if I have average total cost and it's not the same as my average variable, what do I know I'm in? The short run. Okay. So I know that I'm in the short run. So I know that there's going to be some difference in between my average total and my average variable cost. So anytime I'm looking at a problem like this, where I'm given information about what the marginal cost is at a specific quantity, the average total, et cetera, I can draw a visual out. So I know that my average total cost will always have this kind of U shape to it. We then said we're going to have this marginal cost curve. And here would be where when my marginal costs are decreasing, we have gains from specialization. Now, the reason why I didn't add it into the problem, but I would probably do it on the quiz just to guarantee there's no one who could, and it'd be any confusion, is we're only ever concerned about the part of the marginal cost curve where the costs are increasing, because we're trying to figure out where is this efficient quantity or efficient scale of production. Well, we know that if our costs are still going down by hiring more workers, right, as producing more, well, we're lowering our cost. If we were going to produce here, we definitely want to keep producing here. So we know that we're only ever going to stop somewhere on the portion of the marginal cost curve where we have diminishing returns, or marginal costs are increasing. Okay, so I know that at this efficient point, we said that the marginal cost will be equal to our average total cost. And when that's true, it must be at that minimum point of the average total cost curve. Okay. Now, if I have average variable costs, I know those should always be drawn in below my average total. And the difference between my average total and average variable was my average fixed, which I know that as I produce more, I'm taking the same fixed cost, spreading it out over more units. That gap is going to be getting closer and closer. Okay. So in this problem, I told you that at the current quantity of 10, the marginal cost is 20 and the average variable cost is 18. So I know that I'm looking at a quantity. So same kind of idea. My marginal cost will hit my average variable cost curve at its minimum. And let me make sure I've got these values correct before I continue to keep pushing here. Yeah, marginal cost was, oh no, sorry. The marginal cost was 18. And my average variable cost was 20. Okay. So if my marginal cost, I'll get this out of here. I'm at a quantity where my marginal cost is below my average variable cost. So I know that I'm actually looking at a quantity that's down here, where my marginal cost of 18 is below the average variable cost of 20. So what must be true if I increase production here? Well, if I increase production, when my marginal cost is below the average, what's going to be true about my new average variable cost? it must be, when I'm adding a value that's below the average, just like whatever my current quiz grade is, if I don't do as well in the next quiz, it's going to pull my quiz average down. So my new average should be getting lower. Right? So here, if I produce past 10, I go up to that 11th unit, what's happening to my average variable costs? They're decreasing, right? They must be something less than 20. Okay. Now, what would also have to be true, didn't ask it in this problem, but if marginal cost is below average variable, marginal cost is also definitely going to be below my average total. So what has to be true about my new average total cost? It must be going down as well, right? So it's going to be less than what it was before or less than 25. Okay. Now, as I produce more, because I said we have this diminishing portion of the marginal cost curve we're looking at, as I produce more, what's happening to my marginal cost? They should be increasing. Okay. So I can think about here, I know the average variable cost, it's not going up. We said it was going down, so it's not going to be greater than 20. It's actually going to be less than 20. Now, my average total cost, we know that is it going to be less. We know it has to be something above 20, but it is decreasing from 25, right? It has to be somewhere above the average variable cost. And then as we produce more, we said because we've got this diminishing, we've got no gains from specialization, diminishing returns, we know the marginal cost should be higher as well. Right? So being able to draw out this short run cost structure will be important for answering these types of questions. You could also think about, let's say I gave you an example where the marginal cost, I don't know, let's say the average variable cost was 23, marginal cost was 26. Well, if my marginal cost is above my average variable, what's happening to my new average variable cost? It must be going up. So kind of see here, my average variable cost curve, if I produce more, should be increasing. Okay, so it should be something if I go from whatever unit this was, if I increase the number of units, well, now my new average variable cost should be higher than what it was before or greater than 23. Okay. All right. So question 8 was the next one. So we're running out of time a little bit here, but we can get through this. So, okay. So if I have the elasticity of supply and the elasticity of demand, which of the following is true? So we go back to when we talked about this. When we have a tax, and I feel like I must have hit something here, it like zoomed in on me, but if I've got a tax, who is going to bear more of the burden of that tax? Whoever is more inelastic, or whoever is not responding. Okay? What does more inelastic mean? It means an elasticity of supply or demand that is closer to 0. So here we were told the elasticity of demand is negative 0.9. Elasticity of supply was 0.5. Now, in both cases, they're less than, we always know the elasticity for demand will be negative because it's the relationship between price and quantity is inverse. Supply, we're always going to have a positive elasticity because price and quantity move in the same direction. So we're really just thinking about comparing the absolute values. Now, both of these in absolute value are less than 1. So both producers and consumers are going to be inelastic. However, who is more inelastic? So here our suppliers or our producers have a value closer to 0. So they're going to be more, I'm writing when talking, more inelastic. Right? If they're more inelastic, that means they're going to bear more of the burden of that tax. Consumers had a slightly higher elasticity, or they were being more elastic. So if they're more elastic, we would say that they're less inelastic. So that means they're going to be able to avoid more of the burden of that tax. Okay. So whoever has a lower elasticity measure in absolute value, that's going to be the individual who bears more of the burden of that tax, right? So we go back up to look at this tax, who's going to bear more of the burden? If these were the elasticity values, well, it's going to be suppliers were less elastic or more inelastic, so their producers are going to bear more of the burden of that tax. What would have to be true if they were bearing the burden of the tax equally? This would have to be like negative 0.9 and 0.9. It'd have to have the exact same elasticity measure. Okay. All right. Any other questions people want to see? We have 5 minutes here. I got to save a little bit of time to kind of just mention things about the exam again. But so I already mentioned making sure your view, thinking about effective versus ineffective price ceilings. I think if there's anything else that is a common pitfall that I want to make sure people would review. I would really make sure you feel good with these ones where I filled a chart. HHI is going to be a possible answer there, or a possible, highly possible question that you would see. So one thing I would we didn't talk about, but 24 kind of highlights. We can see shifts in our budget constraint that are coming from income changes, but those are also going to be representing another type of change. So let's say I've got any two goods. I forget the exact problem on 24, what the goods were. It doesn't matter. I think the original price of the X good was like 3. Price of the Y good was $1.50, right? So you can kind of think about here, if this was my original budget constraint, if instead the price of my X good went to 6 and the price of Y at the same time went to 3, what did both the prices do? They doubled. So how much can I afford to buy if I'm buying either good? Half as much as I was before. So we can kind of think about what's happened to my budget constraint. Well, when both the prices go up by the same proportion, notice what would be the slope of my budget constraint. So that's always the price of negative price of X over the price of Y. So here it was going to be 6 over 3. Here it's going to be 3 over 150. In both cases, it's the same slope because the relative prices haven't changed. However, can I afford to get to the same level of utility I was before? No, because when the prices both change, it's essentially like I had a decrease in income. So whether or not, right, remember these intercept points are like my income divided by the price of that good. So that point can change if my income goes down, or it can change if the price of that good goes up. So if we have this kind of shift, it can represent a change in income or a change in the price simultaneously of both goods. Okay. Now, if I only have a change in the price of one good, that's going to be where, yeah, it might shift my budget constraint down, but one of the points will stay the same. And now, because it was a change in the price of only one good, my relative prices should now be different, or I'll have a different slope to that budget constraint. Okay. So when you're seeing like these parallel shifts or thinking about kind of what's happening to that budget line, that parallel shift can be caused from either a decrease in income or a change in the price of both goods. In this example, the price of both goods went up by, times 2. So it's actually going to have the same slope. It's not going to be steeper or flatter. It's just going to shift down. Okay. And then if, one of those prices changes, you can kind of think about shifting it will become steeper or flatter is another potential question like that you could be asked. Okay. So once again, these problems are not exhaustive. So anytime you have a problem, think about how I could change it. What if the price of one of these goods only one of these goods went up, or one of these goods prices only went down? Or like in this one, what happened if instead of 10 and 5, what happened if the total effect was that it decreased ramen noodles and increased caviar? Like think of all the different types of, things I could change in a question, and those might be some good kind of additional problems you could kind of work through. Because, if you could look at these long enough, you kind of already know the answer. So try to almost create your own by changing like increase to decrease. And that kind of gives you even more problems you can kind of work through. So that takes us right up to the end of class. Before I stop the recording, just a reminder, Module 8 and 9 quiz, as well as the 4 participation quizzes from those modules, all due by the end of the day today. You'll see that module 10 reading be available after the exam passes tomorrow. You can get that done before we meet in class on Monday. And then exam number 2, you'll be able to access it starting at 11:15 Eastern Standard Time tomorrow. You can get on at any point up until 3:15 to complete it. However, once you start, you'll have an hour and 15 minutes. So you need to start it by at least 2 o'clock if you want the full time. Okay. Other than that, any last minute logistic questions for me before I end the recording here? Okay,